Hello everyone. So, as you could see, it's 11:30 p.m., but I know it's very late, but welcome to the Math ETA Reviewer. So, I already met a few viewers in person, and yeah, I did say I was gonna start recording tonight. So, I will start recording tonight and try to push as long as I could. So, good evening, everyone. So, today we're going to start with patterns. So, let's begin. So patterns, it just uses logic and reasoning, and it's based on a visual representation. Most patterns, when you see them in the exam, will be something like this. There's usually no numbers involved, otherwise that would fall into our other sequences. So let's analyze our first problem. By the way, this board is blank so that I have this is like a questionnaire and this is our solutions sheet. So we're kind of already simulating the ETA environment. So this is our example here. So first and foremost, let's try to view it from a vertical perspective. So as you can see, from a vertical perspective, we have the circle here, and then it suddenly goes here, and it suddenly goes there. Now this is seemingly random, and it looks like the star also somewhat follows a pattern over here, where it's here over in this third, here in this, now it's in the bottom middle, and now it's in the bottom left. But now we can't really find a pattern. It doesn't look like. So we still see a same problem here. It looks like it's kind of random. But let's view it from a horizontal perspective. So we have this circle here, right? And this star here. Now it moves one space to the left and up respectively. Then at this third one, it seems to have merged here. Why? Because both of them converge over here, and hence why you only see the circle there. Here, on the other hand, it looks like our circle has moved one space to the right, and it's now here, but our star has moved one space upwards. So let's repeat that again, and let's see if we have the same logic. So if we move this circle to the right and one to the up again, and it looks like we do have the same logical reasoning. We're getting somewhere now. Next, we have a circle that goes to the left here. Meanwhile, the star goes to the upwards here. And then once again, it looks like we already have a pattern. There seems to be some sort of pattern for each horizontal axis. So if we just follow the same logic I drew here, we can get the answer for number 1. So the number 1 answer will look something like this. We're gonna go up again from here. So we put the star over here. Oh, that is okay. How do I draw the star? Okay, that's a star. Hopefully it's visible. And then since we're going right again, we're going to put the circle over here. And this would be our correct answer for number 1. So I will box all of our answers in red as well. So that's our answer for number 1. So that's how we generate patterns. It's mostly based upon logic, so all you really need to do is do a bit of an analysis, and you will get the right answer. Next, illustrating and defining an arithmetic sequence. An arithmetic sequence is an ordered list of numbers with a common difference. I forgot to put that there because I separated it from the part 2. Yeah, sorry about that, but we have a common difference and we'll get to that later. And each number is a term. So these 3, this 5, this 7, this 9, and this 11 is called a term. So what do we call this mathematically? So we have a sub 1, and that's what we call our first term. So when you refer in a formula to a sub 1, that's what we call first term. Those terms can be used interchangeably. Then the second term would be called a sub 2, the third term would be called a sub 3, and so on. You can keep repeating this as long as you keep note that a sub n, where n is equal to the position in the sequence. So as you could see, so this is the first, second term, third term, fourth term, and so on. So these arithmetic sequence can be finite or infinite. You just need to look out for this ellipsis to indicate that it's infinite. If there's none, it's called a finite sequence. Let me mute notifications. All right, let's continue. So these, to find a term easily, we can use this a sub n, right? The nth term in an explicit formula. Now, an explicit formula is found by, hold on. So basically, what you do is, for me, how do we find an explicit formula? So let's say this one, right? So, oh, actually, this is a bad example. We'll find a different example later on. Yeah, here, we have for number 4. So number 2. So let's generate a sequence with 4 terms whose explicit formula is defined by a sub n is equal to n minus 3. So let's put this in our solution board. This is for number 2. So we are given that a sub n is equal to n minus 3, and we want 4 terms. So we generate a sequence by substituting simply the number 1, 2, 3, and 4 to this equation. So first term is equal to 1 minus 3. 1 minus 3 is equal to negative 2. So second term, 2. Now we're at 2 minus 3. That's equal to negative 1. That's our second term. Third term, that's equal to 3 minus 3. That's equal to 0. And fourth term, that's equal to 4 minus 3. That's why it's 1. So our answer for number 2 is negative 2, negative 1, 0, and 1. So I'll box this and label it as number 2. So all of these will be boxed. Alright, number 3. Generate a sequence whose 4 terms again, and we have an explicit formula of a bit more of a complex number. So let's do this together. So we still want 4 terms, and we have a formula of n over, what's that? N over 2, n plus 1. So once again, we're gonna do the same thing. We're gonna have to substitute the values into our the numbers 1, 2, 3, and 4 to this formula. So let's do first term. That's equal to 1/2 of 1 plus 1, and then that can be simplified into 1/2 2 times 2. So 1/2 times 2 is equal to just 1. Second term, that's equal to 2 over 2. Then we got 2 plus 1. That's equal to just 1 times 3, because 2 divided by 2 and 2 plus 1 is 3, 1 and 3 respectively. So that's just 3. Third term, we have 3 over 2 times 3 plus 1, which is just 3 over 2 times 4. And this is equal to 6. And fourth term, 4 over 2, 4 plus 1. And that can be simplified to, that's 4 divided by 2 is just 2, and then 5. And then we have 2 times 5 is equal to 10. Now, as you could see, there seems to be this seems to be a non-arithmetic sequence. So you shouldn't restrict the explicit formula to just arithmetic sequence. It can be anything. So our geometric sequence would be 1, 3, 6, and 10. So let's box that as our answer for number 3. Number 4, now we get to find the explicit formula. So, number 4, we have explicit formula of 17, 10, 3, and -4. So I'm gonna teach you a little shortcut. You can use this in a solution, I think so. So first we want to find the common difference. The common difference is this term minus this term. So we want to pick a second term minus first term or third term minus second term. It doesn't matter. So let's find the d. So our d is equal to 10 minus 17. That's equal to -7. So d equals -7, right? So to form the explicit formula, I want you to immediately, once you have your d, I want you to attach the -7, right? I want you to immediately put the d right next to it. So you have the common difference, oh sorry, not the d, the n, sorry. So I want you to attach the letter n right next to it, immediately. Then, I want you to use this common difference and reverse the multiplication. So like instead of -7, it's +7 now. So 17 plus 7, because that's the first term, and we'll have a thing called a ghost term. I like to call this a ghost term, and that's the 0th term, and that's 24, because 17 plus 7 is 24. But this ghost term actually helps us attach the second part of the formula, which is 24. Now you might be wondering, why do we do this? Because we need to find the a sub 0, because we'll start substituting n immediately with 1. When we count, we don't say 0, 1, 2, 3, 4. We immediately start with 1, and hence it's important to find the 0th term. So to check if it's correct, let's try to count our a sub 1. So when we substitute n with 1, it should be equal to 17. So -7 times 1 plus 24, that's just equal to 24 minus 7, which is 17. Very good. Let's try it with 2 now. So if we want this to be true, we want it to equal to 10. So -7 times 2 plus 24. -7 times 2 is -14 plus 24, and that is equal to 10. Once you've verified at least 2 terms, you have found the explicit formula. And so therefore, -7n plus 24 is going to be, oops, Siri, do not, okay. And therefore, -7n plus 24 is going to be our, it's going to be our, what do you call this? Our answer for number 4. Alright, I think I have. Alright, so next is the arithmetic series. This is just the basic part of it. So we just need to find the sums of all the terms in the series. So in this case, we just do 2 plus 4 plus 6. That's equal to 12. And this one for 1 plus 3 plus 5 plus 7. That's equal to, put that in your calculator if you need to, but that's equal to 16. So let's box these two as well, because these are answers. So this is number 5, and this would be number 6. So next one, part 2, like I said, we have a common difference, and to find the common difference, you have a technical formula. So the common difference formula is a sub n minus a sub n minus 1. So you take like the second term minus the first term, the third term minus the second term, and so on. So it's very simple. So we have the given over here. 10 minus 5, that's 5. 15 minus 10 is 5, and so on. It should be true for the entire sequence. So now let's try to find the common difference of these ones. So 6 minus 3, that's 3. 9 minus 6, that's 3. So the common difference here is equal to 3. Next, 44 minus 33, 11. 55 minus 44, also 11. So therefore, it's 11. Next, -2 minus -2. Hold on. So -2 minus -1. So negative 2 minus negative 1 is just negative 1, I believe, right? Yeah. So this is an example of a decreasing sequence. So this is, yes, negative 1. So I will box all of this because these are answers. And this is number 7, number 8, number 9. All right. So to ensure that it has a fixed we need a fixed common difference. So if it doesn't, it's not an AS. So we just want to say over here is if it's AS or not. So let's see. Negative 11 minus negative 18 is positive 7. Negative 4 minus negative 11, that's also positive 7. 3 minus negative 4, that's also positive 7. 10 minus 3 is also positive 7. And 17 minus 10 is also positive 7. So this is an AS. Number 10. And then, next one, y plus 1, 2y plus 2 minus y plus 1. So 2y minus y is just y. 2 minus 1 is just 1. So plus 1. Then 3y plus 3. 3y minus 2y is y plus y. And then 3 minus 2 is just 1. So this is also an AS. Okay. But let's see for this one. 12 minus 5, that's plus 7. 19 plus minus 12 is plus 7. 26 minus 19 is also plus 7. But 35 minus 26 is plus 9. And 43 minus 35 is plus 8. So as you can see here, not uniform. So this is not AS. Alright, next. Finding the nth term. Use the nth term formula. So the nth term formula is a sub n equals a sub 1 plus n minus 1 times d. Let's dissect that. So a sub n is equal to a sub 1 plus, right? Plus n minus 1 over d. So our common difference. Let's start with the given. So we want a sub 100, right? So we have a sub 100 is equal to a sub 1, that's our first term, which is 20, plus n, which is our 100th, because a sub n, so 100 minus 1, times our common difference. Let's solve for it. 25 minus 20 is 5. 30 minus 25 is 5. So let's do 5. Please follow order of operations. Let's evaluate the brackets first. So this is equal to 20 plus 100 minus 1 is 99. Next, follow multiplication first. So 99 times 5, that's equal to 495. And lastly, let's do addition. 20 plus 495 is 515. And that is our answer for number 13.
You're reviewing that?
Yep. Okay. Alright, so that's number 13. Alright, number 14. Finding an arithmetic finding how many terms in an arithmetic sequence. So we have this problem over here. It's gonna be the recording video. So yeah. So we have the 22. We have the number of terms here in the arithmetic sequence. We have 22, 14, 6, ... until negative 18. So what we want to do first and foremost, I'll put this on the solution board because we don't have space. So number 14. So first and foremost, we need to know the last term, which is negative 18. And then using the same formula, a sub n is equal to a sub 1 plus n minus 1 over d. No, n minus 1 times d, sorry. Right? Yeah. Alright. So first and foremost, we want to substitute a sub n. We don't know what it is. We do know what a sub n is, which is negative 18. Because that's our last term. And our last term will help identify n. And then we substitute the rest. Okay? So let's see. We have a sub 1, that is, let's recall, 22, plus we keep n minus 1, unknown, times d, which is 14 minus 22, negative 8. 6 minus 14, negative 8. So it's negative 8. So let's simplify. We want to simplify this first. So negative, actually no. Let's transpose it first. Can we transpose it? Yes, we can, right? All right. So it becomes, we transpose the 22 to the other side. So it becomes negative 40 is equal to, let's see. Negative 40 is equal to, let's multiply. Negative 8 times n, negative 8n. Negative 8 plus 1. Sorry. Yeah, negative 8 times negative 1 is plus 8. So let's transpose. Negative 48 is equal to negative 8n, which means we can cancel the negative. So 48 is equal to 8n. Then we divide both sides by 6. So 6 equals n, and that's our answer. So there's 6 terms in the arithmetic sequence. Number 14 is this one. Okay. Probably last problem for today, because it's very late. It's 11:47 already. I underestimated the amount of time. I underestimated the amount of time this might take. So I'll see if I can continue. So solve for the first term of an arithmetic sequence whose fourth term is 34 and whose 10th term is 22. So we do have to do a bit of analysis here. So we want to do, there's another shortcut to this. So we want to find, right, we have 22 over here. So the shortcut is 22 and then over the position, right, 10 minus, and then we put this 34 is equal minus 4 is equal to negative 12 over 6, and that's equal to our difference, which is negative 2. So difference is equal to negative 2. Okay, now we need to do a bit of reverse engineering here. So since we're going backwards, we need to actually flip this. So we want fourth term. So we want to flip this term. So how do I say this? So 34, right? 34, and I want you to count from 4 and then 3, 2, 1. So that's 3 more terms. So we have to times it by plus negative d times 3. So that's just d is negative 2, so negative d is just 2. So 2 times 3 is gonna be 34 plus 4. That's gonna be 40. Sorry, 34 plus 6. Yeah, that's equal to 40. And that's going to be our answer for number 15. So I have covered only 3 points, sadly, and I've taken about 20 minutes. So I really wanted to go slower on this one because it's ETA and there's a lot of technical stuff. So I hope you appreciate the slower pace, but as always, you could always skip the things you're already confident and just skip right to the next one. So let's see if I have the energy to continue this one, because there's still quite a lot. Alright, before we move on to geometric sequence, there's a few topics that I forgot to discuss last night. So as you could see, it's 11:42 a.m. I had a very long sleep. So let's start once again. Welcome back. Okay, arithmetic sequence word problems. So first one is find the value of k, so that 2k minus 7 is and k plus 5 and 3k plus 2 is an arithmetic sequence. So to form an arithmetic sequence, let's just imagine this is a sub 1, a sub 2, and a sub 3. And since they have a fixed common difference, we can say that a sub 3 minus a sub 2 is equal to a sub 2 minus a sub 1. The reason being is because they have, once again, a common difference. So if you subtract these two and these two, they'll have the same number. And these two and these two, they'll have the same number as well. So we can say that. Then we can substitute in the values. We have 2k, a sub 3 is going to be 3k plus 2 in parentheses minus k plus 5. K plus 5 is equal to, so a sub 2, k plus 5 minus 2k minus 7. So let's evaluate this one. So 3k minus k is just 2k, and then 2 minus 5 is just negative 3. Is equal to k minus 2k is just negative k. 5 minus negative 7, that's just 5 plus 7, because minus negative is just plus. So that's equal to plus 12. Okay, then we transposition. We put the negative k to the other side. So that becomes a positive k. So that becomes 3k minus 3 is equal to positive 12. Then we transpose the negative 3 to the other side. So that becomes plus 3. So 3k is equal to 15. Then we simplify, divide both sides by 3. K is equal to 5. And then we can just simply substitute k. So I'll just do it here because we have no more space. So 3k plus 2 is 5 times 3. 15 plus 2 is 17. And then k plus 5, this is 5 plus 5, that's 10. And then 2k minus 7, so that's 10 minus 7, that's 3. So 17, 10, and 3 is our answer for number 16. Alright, next one. I think I'll do this on the side. So let's analyze this problem first. Nigel is planning to conduct his weekly exercise routine. He is thinking of jogging every day, and for every week he'll add 5 more minutes to his jogging time. If he jogs for 15 minutes for the first week, how long will he do it for the 8th week? So let's analyze this problem first. We have 2 clues here. For every week, we have 5 more minutes. So every week is equal to plus 5. And we also have a clue that about his 15 minutes for the first week. So this 15 minutes for the first week is our a sub 1. That's equal to 15. Then we need to find how many minutes he'll need to jog on the 8th week. So we want a sub 8. And this every week is actually equal to your d. So we can just use the nth term formula over here. So that's a sub 1 plus n minus 1 times d. That's equal to a sub 1 is 15 plus 8 minus 1 times common difference as 5. 15 plus 7 times 5. 15 plus 35 is equal to 50 minutes. And this is number 17. Next one. Arithmetic means. This is a new topic. So arithmetic means it is 2 terms between an arithmetic sequence. It's pretty simple. So let's start. To solve an arithmetic means, I want you to do the following. First down, let's list down the first term here, negative 5. Then let's count. 1, 2. 2, right? So plus 2d. The reason why is because we added the common difference twice from negative 5 to get positive 7. And then therefore is equal to the rightmost term, 7. Now, let's find the common difference. We have, how will it, okay, I think I can just, okay, I'll just label the solutions as well, might as well. So negative, this is for number 18, this one. We transposition the 5, the negative 5, it becomes 2d is equal to 12, and divide both sides by 2, d is equal to 6. So therefore, we have plus 6. So this arithmetic mean is 1. Because negative 5 plus 6 is 1. Then 1 plus 6 is 7. So this is the answer for number 18. So 18 solution. Okay. Next one, number 19. We have three geometric, arithmetic. 3 arithmetic. So let's try to do that. So like I said, let's first let's attach 1 to the other side. And then plus, so let's count how many d times we added d. So that's 1, 2, 3, 4. So that's plus 4d is equal to the last term, 21. Transposition, so we put the 1 on the other side. So 21 minus 1, it becomes 20 is equal to 4d. And then divide both sides by 4 is equal to d is equal to 5. So we do plus 5 here. 1 plus 5, 6. 6 plus 5 is equal to 11. 11 plus 5 is equal to 16. And 16 plus 5 is indeed 21. So this is our correct answer for number 19. So I'll just put solution so we go a bit faster. Last one, we have negative 4. Number 20, we have negative 4. And then negative 4. And then plus, how many times did we add d? Let's count. So 1, 2, 3, 4, 5. So that's plus 5d is equal to 36. Alright, then we transposition the negative 4 to the other side. It becomes positive 4. So 36 plus 4 is 40 is equal to 5d. Divide both sides by 5. That's equal to d is equal to 8. So we encircle this, and then we add 8 to each one. So negative 4 plus 8 is equal to 4. 4 plus 8 is equal to 12. 12 plus 8 is equal to 20. 20 plus 8 is equal to 28. And 28 plus 8 is indeed equal to 36. So these are our answers for number 20. Next one, arithmetic series problems. To recall, the arithmetic series is going to be the sum of terms in an arithmetic sequence. So we have 2 different ones here. I have prepared 2 problems to use each one. First one, we're going to use this one. So for number 21, we're going to use the arithmetic series with first and last term. So that's equal to S of n is equal to n over 2 a sub 1 plus a sub n. Alright, so here, what is the sum of the counting numbers from 1 to 100? So 1 to 100 is clearly 100 numbers, so we put s of 100 is equal to, our n is 100 over 2, and then we put this, what's this? A sub 1, which is clearly just 1, plus 100. And then we simplify this. 100 over 2 is just 50. And then we have 101 here. So S of 100 is equal to 5,050. And that's our answer for number 21. Alright, I've been doing this entire thing without a calculator so far, so I'll get my calculator for number 22. Alright, so for our last problem in Unit 1, which is arithmetic sequence and series, is going to be this one. An auditorium has 20 seats on the first row, 24 seats on the second row, and 28 seats on the third row. The theater has 30 rows of seats. How many seats are there in the theater? Now, as you could see, this one relies on the last term to be known. However, we don't know the last term. So we'll have to pull out a more complex formula for this one, which is S of n is equal to n over 2 in brackets. In brackets, it's going to be 2a sub 1 plus, in parentheses, n minus 1 times d. Okay, so let's analyze first. We have our n is equal to 30 because we have 30 seats. Our a sub 1 is equal to 20 because it's first row. Our d, let's solve for it. So 24 minus 20 is 4. 28 minus 24 is also 4. So d is equal to 4. So let's substitute everything. S of n is equal to 30 over 2. Then 2 times a sub 1, 20, and then plus n minus 1, so 30 minus 1 times 4. Okay, a little bit overwhelming. It's okay. I'll simplify it. S of n, 30 divided by 2 is 15. And then 2 times 20 is 40. Then 30 minus 1 is 29. And now we have a more manageable problem. Let's keep simplifying. S of n is equal to, same thing here, 15 plus, 29 times 4, 116 plus 40. So S of n is equal to, S of 30, just say this is 30. I'm so sorry. This is 30, this is 30, everything's 30. So 15, 156, and then lastly S of n is equal to 156 times 15, that's equal to 2,340 seats. Don't forget the label. All right, and that's all for arithmetic, the arithmetic unit. Hold on. So that's all for the arithmetic unit. So actually right now the current video length is around 37 minutes, which is actually a 5-minute time shaving from our original video. So we're still saving time here. So we're gonna get to geometric sequence. That's a little bit more complex, so I will recall that. Alright, for geometric sequence, I decided to go on a different approach. I'll be evaluating the previous assessments we have, so that we can also we probably have similar exams, not the same but similar, so that you can try to learn from your mistakes so that you won't recommit them in the ETA. So this sector is all about geometric sequence, series, and other sequences. Next, alright, so let's continue our number count. Number 23. Which of the following describes a pattern of the sequence 3, 6, 12, and 14? So I'll answer each choice and why it's wrong. The terms increase by a constant difference. It means that it's increasing by a common difference. But as you could see over here, 12 minus 6 is plus 6, and 6 minus 3 is plus 3. So this is the difference that they assume is constant but is not. So therefore letter A is incorrect. Letter B. The terms increase by multiplying a changing factor. So to find this changing factor, they say we need to divide the oops, okay, I just realized I'm in the same layer. It's gonna get messy if I do that. Okay, all right, so here, so if we try to find the constant value, Let's try to solve it once again. So we're going to do changing factor. So 12 divided by 6, that's times 2. So because 6 times 2 is 12. So 6 divided by 3 is also times 2. Same thing here. Which means this answer is also wrong. So letter B is also wrong. And then letter C is each term is the square of the previous term. But as you could see just by looking at it, these are not perfect squares. So these are false. So it only leaves with our answer letter D is each term is obtained by multiplying the previous term by a fixed number, which is times 2. And this times 2 is called your common ratio. We'll be using that in number 24. Number 24. What's the common ratio of the sequence 1 over 8, 1 over 16, 1 over 32, 1 over 64? So to do this, I want you to put in your calculator. We're going to have to, instead of subtracting these two terms, we'll divide. So 1 over 16 divided by 1 over 8. That gives us an answer of, so divide these two terms. That's equal to 1 over 16 divided by 1 over 8 is equal to half. 1/2. And our answer is letter A. Next, find the 17th term in the Fibonacci sequence. So Fibonacci sequence is very famous. It adds the first two terms to get the previous two terms to get the third term. So it's very simple. We just need to keep adding until we have 17 terms. We're given 3 right now. So it's going to be tedious, but let's do this together. So for the fourth term, that's 1 plus 2 equals 3. For the fifth term, 2 plus 3, that's 5. For the sixth term, 3 plus 5, that's 8. For the seventh term, it's going to be 5 plus 8, that's 13. Then for the eighth term, it's going to be 13 plus 8, that's 21. For the ninth term, it's going to be 13 plus 21 is equal to 34. For the next one, it's going to be 21 plus 34 is equal to 55. This is going to be our 10th term. So next is our 11th term, 55 plus 34. That's equal to 89. For our 12th term, we have 55 plus 89. Ooh. Heck. Is equal to 144. So we can just keep repeating this. So 144 plus 89. 144 plus 89. The next one is 233. 233 plus 410 is equal to, I'm encountering some technical difficulties here. Sorry. This one's 377. Then the next one is plus 233. Oh my gosh. What the heck, man? Hold on. Our calculator is malfunctioning, but this is 610. That makes our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is our 15th term. And our 16th term would be 987. And our 17th term as requested is going to be 1597. So the answer here is C. Next one, which is not true about the geometric sequence -5, -5, -5, -5, infinity. So let's see. Hold on. Alright, so sorry for the technical difficulties. I'm gonna buy a new calculator, I promise, before ETA. Alright, which is not true about the geometric sequence -5, -5, -5, -5, -5. So like I said, so first and foremost, r is equal to -1. So if we multiply this by -1, -5 times -1 is actually +5. So this is false. This is false. Yeah, this is false. So we already know it's letter A. For letter B, it's a sub 1 is -5, which is clearly true. So this is also true. For letter C, it says that the sum of first four terms is -20, and -5 plus -5 plus -5 plus -5 is indeed -20, so this is also true. And a sub n, or any term, is equal to -5, and it's clear, so this is also true. So this is A. Alright, next. The expression 4 plus -16 plus -64 plus 256 plus 1024 represents a finite geometric series. So it is indeed a series because it's a sum of terms, but it's not geometric because it can either always be all positive, so 4, 16, 64, 256, 1024, all negative, -4, -16, -64, -256, -1024, or alternating, so 4, -16, 64, -256, 1024. But since we have two consecutive terms of negative and then just some random positives over here, this cannot be a geometric series. So therefore, because of that fact, it's false. Next, the next three terms of geometric sequence is 1, -1/3, and 1/9. So let's solve for the common ratio. So to find the common ratio, just divide the second term by the first term. So -27 over 81 is equal to r, and -1/3 is equal to r. We just simplify. So let's try to do this. So -3. So alright, so so our next one to do is -3 shift. So we have, so -3 times our r is indeed 1. So far it's looking good. So 1, let's try to do our, let's try to do it again. 1 times our r. So 1 times -1/3 is -1/3. So far it's correct. Then -1/3 times -1/3 is 1/9. So it's also correct. So therefore this statement is true. So this type of question is the one that I actually did not say in a geometric series video. So it's the sigma notation. So the sigma notation is going to be where we substitute each one of these numbers from 1 to 5 using this k squared here. So let's try to solve it. So 1 squared is just 1 plus 2 squared, so that's 2. 2 squared is equal to 4, so it's already false. So 3 squared is equal to 3, so 4 squared is equal to 16. And 5 squared is equal to 25. Why? Because we just substitute each number from 1 through 5, each integer from 1 to 5 with this formula, which is just squaring it. So this results in a different sequence. So therefore, the sequence listed here is different from the sequence we derived. So this is false. Next, this is harmonic sequence. So for harmonic sequence, it's basically the reciprocal of arithmetic sequence. So to do this 1 over 3, just make it 3 over 1. So just 3. 6 over 1 becomes 6. 9 over 1 becomes 9. And 12 over 1 becomes 1 over 12 becomes 12. So we just reciprocated it. And do they have a common difference? Yes, they have 3 common difference. So if there's a common difference and it satisfies all the traits after reciprocating, you can solve for a harmonic sequence. So therefore, this answer is true. Next one, insert 4 geometric means between 3 and 729. So this is actually very similar to arithmetic means. So arithmetic means, geometric means, 3. So we got blank, 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 and 729. So like how I did it, so we have to make an equation here. So 3, our first term, is equal to, this is our r, times r, times r, times r, times r. So r times r times r times r times r, or r raised to 5, is equal to 729. So what do? Let's divide both sides by 3. That's equal to 243 is equal to r raised to 5. And then if you don't have the solve button, it's okay. You can just find this manually because we can't find this manually, but we can take the fifth root of 243. So every calculator has the fifth root. So the fifth root of 243 is 3. So our r is equal to 3. So with the r in mind, we can do times 3, that's 9, times 3, that's equal to 27, times 3 is equal to 81, and times 3 again is equal to 243. For verification purposes, times 3 is at 729. Yes, it is. So this is our answer for number 31. Let me box that. Alright, number 32. Find the sum of the geometric sequence 10, 24, 256, 64, 16, ... So recall what I said. Is this a finite or infinite geometric sequence? It's an infinite because of these ellipses over here indicating it goes on forever. So we're going to use the infinite geometric series of infinite. So we got a sub 1, 1 minus r. So our a sub 1 is clearly 1024 or 1024. And we just have our r. So r is equal to 256 over 1024. Or r is equal to 1 over 4. Now we can just very much substitute. 1024 minus 1 minus 1 over 4 is equal to 1024 over 3 over 4. But this needs to be simplified. That fraction at the bottom needs to be simplified. So to cancel out the over 4, we need to multiply this numerator by 4. So it becomes just over 3, but we have to multiply by 4. So 1024 times 4. That's 4096 over 3. So the answer is 4096 over 3. And that is our answer. Alright, so I've been recording since I woke up. It's now 12:30. I'm probably gonna eat lunch. I'll be back around 1 p.m. Alright, so at the back of the page, we have a situational analysis. So let's read it. The DLSZ Social Action Office, SAO, launched a book donation drive to support the nearby community libraries. During the first week, the office successfully collected 4 books. As more students joined the cause, the number of books donated tripled each week. The office continued to record the number of new books donated each week. Within a 2-month period, there are exactly 4 weeks in each month. how many books will be donated during the 5th week, and what's the total number of books donated over the 2-month campaign. So first and foremost, we need to solve for letter A. Letter A is only looking for how many books will be donated in the 5th week. So therefore, we can use this formula, nth term geometric sequence. So it's going to be A sub 1 is A sub n is equal to A sub 1 times R minus n raised to n minus 1. Sorry. So A sub n is going to be A sub 5 because we want the 5th week, right? Is equal to A sub 1, which is 4 books. Why? Because it's going to be first week, 4 books. So that's first term. R is donated tripled each week. So triple meaning times 3. So 3. N is equal to 5 minus 1. Simplify. 4 times 3 raised to 4 is equal to A raised to 5. So let's put that in our calculators. So 3 raised to 4, that's equal to 81. 4 times 81 is equal to A sub 5. A sub 5 is equal to 324 books. So in the solution, make sure to add books. 324 books, and oh, I forgot to label the numbers. Hold on. This would be number 33. This would be number 34. And this would be number 35. And I'll explain for number 36. Alright, okay. So, next one. What's the total number of books donated over the 2-month campaign? So we're gonna have to use another formula we haven't used, which is the G series finite, because we didn't go for an infinite amount of time. We went for a finite amount of time, which is 2 months. So let's copy our formula. S of n is equal to A sub 1 R raised to n minus 1 over... Wait a second. Did I list it down wrong? I think it's 1 minus R. Hold on. Hold on. Let me technically... Okay, so I was recalling it, and the one that I previously wrote was actually correct, but the one that we're more used to is this one. So it's A sub 1, in parentheses, 1 minus R raised to n over 1 minus R. So let's use that one instead. So S of n, so we need to find n first. So we have 2-month period and 4 weeks in each month. 2 times 4 is 8. So 8 weeks. So our A sub 1 is equal to 4 as previously mentioned. Then we have 1 minus R, which is 3 previously mentioned, raised to 8 over 1 minus 3. Let's simplify. 3 raised to 8, that's equal to 6561. So sum of 8 is equal to 4 over 1 minus 6561 over 1 minus 3. Simplify further. S of 8 is equal to 4 times negative 6560 over negative 2. Because 1 minus 6561 is negative 6560. And then we just simplify this again. Negative 6560 times 4. That's negative S of 8 is equal to negative 26,240 over negative 2. And then continue up here. S of 8 is equal to 13,120. So the answer is 13,120 books. Add labels, guys. Add labels. That's going to be number 34. Okay, number 35. Suppose the school book storage room can only hold 10,000 books. Will it reach full capacity by the end of second month? And the answer is, I misread this question. The answer is, of course, yes. Because 13,120 is bigger than 10,000. So we want to explain and defend our answer. So I said that the school can expect 13,120 books based on current trends. And I also stated that it's greater than 10,000, so it cannot hold all books. Now, this isn't really the best way to explain it. I still got full merit. But the better way of saying this is that it's greater than 10,000, so it will reach full capacity. But even still, this is still correct. And I also added that if the program was only 7 weeks, the library could still manage with 4,372 books. So all in all, for open-ended questions like this, you just have to add the answer and maybe add a supporting detail of the opposite. So as you could see over here, I said the answer, and then I also put a hypothetical scenario where it could have been the opposite result. So just like that, let's take down one by one if we manage to cover all topics. So we definitely define the geometric sequence, that's for sure. We differentiate a geometric sequence for an arithmetic sequence. Yep, I did say that. We had geometric means. We had the nth term of geometric sequence. We had the sum of those. Geometric terms in a finite or infinite. Yes, we did. So this is finite and this one is infinite. So that's also another check for us. We definitely solved the problem involving these types of sequence in series, and we did have over here harmonic and the sigma notation and the Fibonacci sequence. So we definitely did this, and it looks like we have a duplicate here, so I just assume we also solved that. So look at this. Yeah, we're looking in a much better situation right now. It looks like I might be finished before like 4 p.m. But yeah, this is this unit 3 is pretty tough. So yeah, I'll see you then. Alright, our next topic is new to us, and it will be fundamental counting principle and some of the permutations. Alright, so counting techniques. We have the first concept called factorials. Factorials are something like here in number 37, where 5 factorial is 5 times 4 times 3 times 2 times 1. It's basically all the factorial, all the numbers, the number multiplied by itself, and then we keep adding, multiplying all the numbers until we reach 1. So let's put this in our calculator. 5 times 4 times 3 times 2 times 1, or simply if you have factorial button, 5. Serious technical difficulties again. I swear. Okay, like I said, 5 factorial. If we have this in the calculator, we put 5 factorial. It's the exclamation point, which is equal to 120. Second one, it's 2 times 4 factorial. So like I said, so the visual representation is like this. So 4 factorial is 4 times 3 times 2 times 1. And then, yes, we just multiply that answer by 2. And then if you put this into your calculator, it's equal to 48. Next, 3 factorial times 4 factorial. So 3 factorial is just 3 times 2 times 1. And 4 factorial is 4 times 3 times 2 times 1. So if we put this in our calculator, 3 times 2 times 1, close parentheses, then 4 times 3 times 2 times 1, close parentheses, that's equal to 144. Then we have 7 factorial over 4 factorial. If we expand the format, it looks like 7 times 6 times 5 times 4 times 3 times 2 times 1. And then we have 4 times 3 times 2 times 1 at the bottom. Since they share 4 times 3 times 2 times 1, we can cancel it. So it's just going to be 7 times 6 times 5, which is equal to 210. Lastly, we have 5 factorial over, in parentheses, 8 minus 2 factorial. So we have 5 factorial over 6 factorial. when we expand it, it's 5 times 4 times 3 times 2 times 1 over 6 times 5 times 4 times 3 to 1. They share a 5 times 4 times 3 times 2 times 1, so we have a total of 1 over 6. So we have the 6 from the denominator here, and since we canceled everything in the numerator, we just put 1. So let me just box all our answers. And let's number them so that you can use this while checking out the raw files later in the which I'll be posting. Alright, next is a listing method. This is part of fundamental counting principles, so let's read the problem. A breakfast meal set consists of a sandwich, a drink, and a drink. You may choose ham, hot dog, bacon, or tuna for the sandwich, and coffee, milk, or chocolate for the drink. How many possible breakfast sets are there? Let's put this in our solution board. So this is number 42. So we have our options. This is called the listing method, and it's a visual representation. So we choose ham, hot dog, bacon, or tuna. And for the drink, let's put this as S. And then for the drink, we have milk, coffee, milk, and chocolate. So for the simplicity's sakes, I'll be saying this is S1, S2, S3, S4, and D1, D2, D3. So we have, first and foremost, let's do the ham. So S1, we can also, and then we choose a drink. So it's gonna be D1, D2, and D3. But we can also have S2. S2 is our hot dog, which once again we can pick any drink. So S1, S2, D1, D2, and D3. And then we can just repeat for everything over here. So for S3, which is our bacon, we have D1, D2, and D3 once again. And lastly, for S4, once again, we have D1, D2, and D3. So as you could see over here, how many outcomes do we have? We actually have 12. So we count the ones at the end, that's how many outcomes we have. So we have 12 outcomes. But as you may know, this is not the most efficient way to solve this. That's why we have the fundamental counting principle, which is this one. It's a mathematical rule that allows you to find the number of ways that a set of events can occur. So if an event consists of many ways or steps, the first of which can be done in P ways, the second can be done in Q ways, and so on, we just can multiply them. So since we have multiple ways over here, we have 4 ways over here and 3 ways over here, the simple explanation to do that is just 4 times 3, which is also 12. So knowing that, let's try to solve number 43. Number 43, Carlo is planning to buy a new car. Let's put that in our solution board. 43. Carlo is planning to buy a new car. He can choose between manual or automatic transmission. So that's gonna be, let's put this as 2 transmission types. Transmission. And then we also have 5 possible colors: silver, black, white, blue, or red. So we have 5 colors. And then we can also choose between a 4 or 6 seater car. So 2-seat type. Like the fundamental counting principle, we have a multiple steps of choosing a car. So we have 2 ways of choosing its transmission, so that's 2, and then 5 ways of choosing its color times 5, then 2 types of seat configuration times 2. That's equal to 20. So 2. So 5 times 5 times 2 is 20 ways to choose the car. And that is our answer. This is our answer for number 43. Alright, for number 44. In the Philippines, a former license plate can consist of 3 letters followed by any 3 digits. So let's answer number 44 and 45 simultaneously. So we have number 44, it's like this. Letter, 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 number, number, number. Alright, so it said there's no restriction, so we can repeat. So it's any 3 letters and digits, so it's gonna be any letters. So just to make sure you guys know, it's gonna be the English alphabet or Latin alphabet, which has 26 letters. So times 26 times 26. Then we also have numbers, which is 10, 10, 10, or sorry, digits. So we have 3 different digits, so it's 10 times 10 times 10. So let's type this in our calculator. 26 times 26 times 26 times 10 times 10 times 10. Please do not technical difficulty in the calculator. Thank you. Sorry about that. Anyway, we get a total of a pretty large number, 17,576,000 combinations. And that is our answer for number 44. Alright, number 45. Same problem, we have this any digits, but this time there's going to be a restriction. There will be no repeating letters and no repeating numbers. So we have the same thing here. L, L, and L, and another number. So at first, of course, we can pick any letter, 26. But here's where it gets interesting. We already picked one letter here. So that letter we cannot repeat again. So we need to minus 1. 26 minus 1 is 25. And then same thing here. We already picked 2 letters here, so 26 minus 2, 24. Same thing here. We start with 10 digits, but now we picked one is 9, and now it's going to be 8 because we already picked the previous digits and repetition is not allowed. So once we multiply all of these, we do 26 times 25 times 24 times 10 times 9 times 8. That's equal to 11,232,000 combinations. Oh, sorry, permutations. I think it's Yeah, it is permutations. Sorry, permutations. Or let's just make it simple. License plates, LP. Let's make it LP. License plates, and that's going to be number 45. Alright, next one. Linear permutation. Linear permutation is very simple. We can just use the n factorial we learned from a while ago. So let's answer number 46. So in number 46, how many ways can 5 students be seated in a row of 5 chairs? So you have 1, 2, 3, 4, 5, and 5 students. So for the first one is 5, any of the 5 students can sit here, so 5. Times, for the second one, 4 students can sit here because one's already seated, times 4. For the third one, we have 3 students that can be seated because we already have 2 seated. 5 minus 2 is 3. Then we keep repeating until we reach the last one. Put it into the calculator. 5 times 4 times 3 times 2 times 1 is equal to 120 ways. And that is our answer for number 46, right? Number 47. In a 4-runner sprint, all runners finish the race without a tie. How many finish orders are there? So since without a tie, we can just do the same thing here. So there's 4 places. So let's see. So we have 4 runners that can take first place, then 3 runners that can take second place, 2 runners that can take third place, and 1 runner takes the last place. So it's just 4 times 3 times 2 times 1, which is 24 ways. And that's our answer for number 47. Next one, permutation of n objects taken r at a time. So basically, it's using the how do I say this? It's using this formula where if you have this button, the NPR, we can just put n and r right next to each other. So, or it can be expanded to n factorial over n minus r factorial. So let's do this. So let's put this in our solution board. This is number 48. So we have the 3 students at a time. And we also have 6 total. So like I said, a photographer wants to take 3 pictures, a picture of 3 students at a time with the 6 awardees. How many different lineups are there? So using the formula, or you can just simply put our setup in the shortcut for calculator is a 6 p, is it, yeah, right? NPR? Yeah, NPR. 6p3 on the calculator. So 6p3, which will already give you the answer of 120. But let's expound on it. So we have the formula n factorial over n minus r factorial. So that's equal to 6 factorial over 6 minus 3 factorial. So let's try to put 6 factorial over 3 factorial in the calculator. So 6 factorial divided by 3 factorial is equal to the same answer of 120. So that's 120 ways. And that's our answer for number 48. Next one, number 49. In a DLSZ chorale concert, there are 6 empty seats in a row. How many ways how many ways can 4 high school and 2 grade school students be seated in a row if the students from each group must sit together and the high school students must sit together? So we have to do a bit of problem analysis. I'm going to represent the high school students in red while the grade school students in green. So for number 49. So let's say we have 6 empty seats. So we have these empty seats. So high school students must sit together. The students of each group must sit together. So we must clump both of the 4 high school students into something like this, and the 2 grade school students into a consecutive row, something like this. So that's one scenario. Then we also have to add the formula. So that's 4 times 3 times 2 times 1, as well as 2 times 1. But there's also another case. So we have if the grade school students go first. So it's 1, 2. So that's 2 times 1. And then we also have the high school students also going next. So this is 4 times 3 times 2 times 1. And then so we can just add these together. So 4 times 3 times 2 times 1 times 2 times 1. And we have 2 different cases. That's equal to 96. So let's just do this. So this is 48. This is 48. This is 96 ways. And that is going to be our answer for number 49. Alright, congratulations. If you made it this far and if you've read everything so far, this is your 50th problem. So good job. This is really quite a milestone. So let's add a yay. Yeah, there, a little star. There you go. Alright, number 50. Let's do this together. So what if only high school students must sit together? So there's once again we have these cases. So let's just copy this one, because these are already sitting together. And we also have a third case where the grade school students are completely separated. So we have red, so high school, high school, high school, high school, and we have 2 grade school students over here. So that's also another 4 times 3 times 2 times 1, and then another 2 times 1. So let's put this into our calculator. It's okay, the order doesn't matter. And we also get another 48 ways. So 96 plus 48 is equal to 144 ways. And that's our answer for number 50. Okay, next one. Number 51. How many circular permutation? So it's just the circular permutation formula is just n minus 1, where n is the amount of subjects. So how many ways can 7 people be seated in a round table? That's just going to be 7 minus 1 factorial is equal to 6 factorial, and that's equal to 720 ways. It's that simple because the way we rotate the circle, that's how many times we have to double count. So that's why we do 7 minus 1. So, oh, by the way, these are all permutation, and permutation is order important. This is going to be our key difference in permutation versus combination. All right, number 52. How many ways can four people be seated on a circular table? So that's just going to be 4 minus 1 factorial is equal to 3 factorial. 3 factorial is equal to 6. 6 ways. And that's our answer for number 52. All right, permutation with repetition. The formula of permutations with repetitions when arranging a set of objects where some objects are indistinguishable, aka duplicates. The formula is, okay, it's written kind of badly, but it's n factorial over n sub 1 factorial, right? Yeah, n sub 1 factorial, n sub times n sub 2 factorial, and so on, until we have no more duplicates. So let's see this. How many distinct permutations can be formed with the letters of communication? So the first is to count how many letters. For these word type problems, it's count how many letters there are. So C O M M U N I C A T I O N. So it's gonna be 13 factorial because of the letters. But let's count the duplicate letters. So we have 2 C's, so that is 2 factorial, times, we have 2 O's, that's another 2 factorial. Let's see if we have more. We have 2 M's, we have another 2 factorial. We have 2 I's, that's another 2 factorial. And do we have any more? We have 2 N's. So that's another 2 factorial. So we have this formula over here. So let's put into the calculator. 13 factorial divided by parentheses 2 factorial times 2 factorial times 2 factorial times 2 factorial times 2 factorial is equal to... Alright, it's okay if it's normal to get a very, very large number. But that large number is... Oh no! Do not... Are you serious right now? A calculator. Alright. Sorry about that. But this is equal to... It's okay, it's a very large number. 194,594,400 permutations. And that's our answer for number 53. So I have to catch a meeting in quite literally 8 minutes, and I'll be out for the rest of the day. So I'll be back once I'll be back. But we're in the last cycle. Okay, there's literally 2 more slides that I have to, 2 more sets of slides that I have to go through. I've gone through so many slides to make this. So thank you guys for reaching this point. All right, I'll see you then. And by the way, before I leave for a few hours, we are already over here. Okay, we have 3 more points, and it's just combination. Alright, so I aimed for 60 items because The longest ETA I've ever taken is an English ETA with 60 points, which could very well be much 60 items for math. So just in case, I want you to expect how really complex the math and science ETAs can be. So yeah, it can be really this long. It can be really this long if we're not prepared. So I'm preparing you. So for number 50, so let's start with combination. So combination, it refers to an arrangement of n objects without repetition, but the order is not important. So in permutation, the order is important, but in combination, it is not. And we have this formula over here. Let's just take note of it. I really can't cram any more formulas. I mean, I could cram it there, but like, yeah, you know what? I'm not even gonna try to write it there. It's gonna get really messy. So the notation is C in parentheses and R, or you can use in your calculator the NCR button. It works very similar to the NPR button, which you can also use for permutation. So visually speaking, if we have the two, if we have the pairing a permutation versus the combination of taken three taken two at a time, as you could see over here for permutation, as you could see, we have A, B, and B, A. So these are, according to permutation, since order is important, A, B, and B, A is not the same, because it's considered different because the letters are swapped. However, in combination, A, B, and B, A are the same because order doesn't matter. It considers them both. Similar with AC and CA, similar with CB and BC. That's why when you put these numbers, so if you do the 3 and then you click NPR and your calculator 2, you get 6. But if you click 3 and then NCR on the calculator and click 2, you get 3. That's the difference between permutation and combination. One permutation considers the fact that the order matters, while combination ignores it. So let's try these examples. Example 1, or should I say number 54. Number 54. In how many ways a teacher can form a group of 5 students from a class of 5 GEM students and 28 non-GEM students if there's no restriction? So number 54 says no restriction. So we want to take 5 students from a group of 5 plus 28. That's equal to 33. And then, since we're using combination 5. So, expounding on this using this formula, so our n is our 33 and our r is our 5. So, we expand it by saying 33 factorial over 33 minus 5 factorial times 5 factorial, which is just 33 factorial over 28 factorial times 5 factorial. So let's take a look and see that in our calculator. 33 factorial divided by, in parentheses, 28 factorial times 5 factorial. We should get about an answer of, okay, another technical difficulty. Come on. $237,336 ways, which is actually expected because we're dealing with quite some large factorials. So that's our answer for number 54. But what if for number 55? Number 55 needs exactly 2 GEM students. And unlike, now we need to kind of split the two, what do you call this? The two groups, the GEM and the non-GEM, into separate categories. Hence why, let's focus on the 2 GEM students first. We want to pick exactly 2, so out of the 5 GEM students, we need 2. So therefore, NCR, where N is 5 and C, and then we have 2, because we're taking 2 GEM students from the 5. And then we have the remaining 28. So 28 C. Now, since we have 5 members in the group, but 2 are GEM students are already taken, we do 3 instead. This is equivalent to 5 factorial over 5 minus 2 factorial all over 2 factorial, right? Times 28 factorial over 28 minus 3 factorial times 3 factorial. Simplifying this, we get 5 factorial times 3 factorial times 2 factorial times 28 factorial over 25 factorial times 3 factorial. So let's take a look at this in the calculator. So our first equation... Are you serious right now? My calculator is refusing to work. Okay, 5 factorial divided by 3 factorial times 2 factorial is equal to... So this is equal to 10 times 28. Are you serious? 28 factorial divided by 25 factorial times 3 factorial is equal to 3,276, and then times it by that is 32,760 ways. And that's our answer for number 55. Alright, I'll try to fix the technical difficulties here. It's really frustrating. I'm already down to my last 5 problems. Come on! And my calculator is not freaking cooperating. Alright, so I think I have a solution to my technical difficulties. I'll just, since my calculator is solar powered, I'll just shine a flashlight at it. And it should work as a... Oh great, the flashlight is not working either, but let's do it. Number 56. NASA is choosing 6 scientists and from 6 scientists and 10 mathematicians to form a committee for its next outer space project. How many different committees with 7 members can be formed if, number 56, no restrictions? So number 56 is just simply choosing from these 6 scientists and 10 mathematicians. So we have 16, and then we have C. And then how many do we need? 7. 16, C7. Thus equal to 16 factorial over 16 minus 7 factorial times 7 factorial, which is just 16 factorial, 9 factorial, 7 over 7 factorial, which if you put on the calculator is 16 factorial divided by 9 factorial times 7 factorial is equal to 11,440. Let me just check. Okay, yep. 11,440 committees. And that's your answer for number 56. Alright, for number 57. So for number 57, where's my mouse? Okay, there. Alright, sorry about that. Number 57, we want only 2 scientists. So, from out of the 6 scientists we have, we want 2 scientists. So that's equal to 6 C2 times the remainder 10 mathematicians. And then since we already have 2 taken slots, is 5. So this is equal to 6 factorial over 6 minus 2 factorial. 6 minus 2 factorial, 2 factorial times 10 factorial over 10 minus 5 factorial, 5 factorial, which when simplified is 6 factorial over 4 factorial times 2 factorial times 10 factorial, 5 factorial times 5 factorial, right? Oh, sorry. Huh? Hold on, what? Is there an error? I think there's an error in this. Hold on. Oh, wait, I'm looking. Okay, let's solve this. So if we do this mathematically, 6 factor, how it's intended, it looks like to be there's a visual error. Let's see. Divided by 4 factorial times 2 factorial. That's equal to 15 times 10 factorial times 5 factorial, divided by 5 factorial times 5 factorial. That's equal to 252 is equal to 3,780, which is our correct answer. So it looks like our presentation's wrong, so I'll point that out. Let me cut the video here real quick. But this answer is correct. So that's number 57. Last 3 problems. Okay, number 58. I've clarified it, but it's all good. So number 58. All are mathematicians. So out of all 7, so we are only gonna be restricting to picking from the 10 mathematicians, which means 10 C7, because since we're only looking at mathematicians and we need 7 of them, so we pick 7 out of the 10 mathematicians. This is equal to 10 C7, and this 10 factorial over 10 minus 7 factorial 7 factorial, which is equal to 10 factorial 3 factorial 7 factorial. So when we put that in the calculator, it's going to be 10 factorial divided by 3 factorial times 7 factorial, which is 120 committees, which is correct. The answer for number 58. Second to the last one, number 59. Okay, we're nearly there, guys. For number 59, we want 3 of the members are mathematicians. Exactly 3. So 3 of the members are mathematicians indicate that we need to pick out of the 10 mathematicians, we need 3. And then the other 4 can be scientists. So 6C4. So once we do this, we have 10 factorial over 10 minus 3 factorial 3 factorial times 6 factorial over 6 minus 4 factorial 4 factorial. That's equal to 10 factorial 7 factorial over 3 factorial times 6 factorial over 2 factorial times 4 factorial. Simplifying this, we get 10 factorial divided by 7 factorial times 3 factorial is equal to 120 times 6 factorial divided by 2 factorial times 4 factorial. That's equal to 15. And 120 times 15 is 1,800 committees. And that's our answer for number 59. Lastly, number 60, and we don't have space. No, I'll find a way to fit that in there. So 1 is assured to be part of the committee. So since this one slot is already taken, but there's 6 other slots, and 15 other members, because 16 minus 1 is 15, so it's 15 C6, which is 15 factorial over 15 minus 6 factorial. So, 6 factorial, there. And that's equal to 15 factorial over 9 factorial, 6 factorial. That's equal to, put that in the calculator, 15 factorial divided by 9 factorial times 9 factorial times 6 factorial is equal to 5,005 committees. And that is our final answer for your math ETA, with 60 problems solved. And yep, let's just confirm. Let's make sure that we answered everything here. So we defined and illustrate and solved a combination of objects, definitely. All right. Then we have differentiate permutation from all right, yep. There we go. I showed the visible, and we definitely solved 7 problems involving permutations and combinations, which means we're once again complete. I've used 4 pages, so let's save this up. And that right there, guys, is your math ETA. So I was supposed to release that tonight, but I mean, you saw it. It was literally midnight or 11 p.m. when I got home. So yes, it gets released on Saturday instead of Friday. But rest assured, at least it's done. So thank you all so much for the support, and I'll see you guys in the next one. Take care of yourselves and good luck with the exam. Thank you guys. Bye-bye.